Imagine the universe as we know it: stars, galaxies, planets, time itself, slowly drifting in a calm, endless darkness. Everything we see today began in a single moment called the Big Bang. It was the start of space, the start of time, and the start of every atom that would someday form worlds and life. But this simple explanation raises a quiet, powerful question. If the Big Bang created everything, then what was there before it? To explore this question, let's take a gentle step back. Think of a book. When you open to the first page, the story begins. But the page itself is not the beginning of the book. Something had to make the page. Something existed before the story started. In the same way, the Big Bang might not be the true beginning, just the first page we can see. Scientists often compare the early universe to a balloon. When you blow up a balloon, the surface expands. The galaxies in our universe behave in a similar way, moving apart as space itself stretches. Now imagine shrinking the balloon down, smaller and smaller. As it shrinks, the surface becomes tighter, hotter, more intense. If you shrink it far enough, you reach a point the size of almost nothing, and that point is how our universe began. But here is the important part. The balloon must exist before you inflate it. Something must exist for expansion to happen. Now picture a calm, empty ocean before a storm begins. The waves have not formed yet, but the water is already there, waiting. Some scientists think the universe might be like that. Before the Big Bang, there may have been a silent, smooth state, a kind of cosmic calm, waiting for something to disturb it. That disturbance could have been the spark that started everything. Another way to imagine this is to think of a seed. Before the tree exists, the seed holds all the potential. Nothing has grown yet, but the ingredients are there. The universe might have had a similar seed state, not full of matter or light, but full of the possibility to become something. There's a gentle idea in modern physics that space itself might go through cycles: expansion, collapse, and rebirth. Like a heartbeat, the universe could experience phases, one universe ending, another beginning. If this is true, the Big Bang might not have been the first beginning, but simply the latest chapter in a much older story. A story with previous universes rising and fading long before ours. For now, we cannot see beyond the Big Bang because it marks a limit of our tools. Our physics stops working as we approach that moment. It is like trying to look through frosted glass. You can sense something is on the other side, but you cannot make out the details. Yet the clues suggest there might be more to the story. Slight patterns in the background radiation of the universe. Tiny fingerprints left behind from before time began. Whispers of an earlier chapter. Imagine standing at the edge of a deep forest at night. You cannot see what lies beyond the first row of trees, but you can feel the space continuing. You sense the distance, the depth, even though it is hidden in darkness. The time before the Big Bang is like that forest, silent, unknown, but not necessarily empty. Some theories suggest a quantum foam, a restless sea of tiny fluctuations, little bumps of energy appearing and disappearing. If one of those bumps grew large enough, it could explode outward and become a universe. In this view, the Big Bang was not the beginning of everything, but a moment when a tiny spark grew into something vast. Others imagine a different picture, that our universe exists inside a larger, higher dimensional space, and that the Big Bang happened when two enormous structures collided, like two waves meeting on the surface of a lake. The collision would create heat, light, and expansion. In this case, something existed before the Big Bang, the structures themselves. And then there's the quietest possibility of all. Maybe the concept of before does not apply. Maybe time itself began at the Big Bang, the way a line begins at a point. Asking what happened before time might be like asking what is north of the North Pole. But even this idea leaves a question. Why did time start at all? As we move through this documentary, we will explore these ideas slowly and clearly. We will imagine what the universe might have been before the first light appeared. We will explore cycles, collisions, quantum seeds, hidden spaces, and the possibility of earlier universes whispering through the fabric of our own. For now, let one simple thought rest in your mind. The Big Bang may not have been the starting point of everything. It might have been just one moment in a much larger and older cosmic story. To explore what might have existed before the Big Bang, we first need to understand why the Big Bang looks like a beginning at all. When scientists look deeper and deeper into space, they are also looking further back in time. Light takes time to travel, so the farther away we look, the older the light becomes. Eventually, we reach a point where the universe was extremely hot, bright, and dense. This is the earliest light we can observe, the afterglow of the Big Bang. But beyond that point, everything becomes hidden. The universe was too dense for light to move freely. It is like trying to stare into a thick fog. No matter how hard you look, you cannot see past it. This creates the illusion of a beginning, a hard wall in time. But a wall does not necessarily mean nothing is on the other side. It simply means we cannot see through it. Many ideas in modern physics now suggest that the Big Bang might be the edge of our vision, not the edge of reality. To understand this, imagine standing behind a closed curtain. You hear voices and movement on the other side, but you cannot see who is speaking. The curtain is not the end of the world, it is just the limit of your view. The early universe works the same way. We reach the curtain of the Big Bang, but we suspect something may lie behind it. One idea is called the bounce. It imagines the universe as a breathing system. First, it expands, then slows, then compresses again, eventually reaching a small dense state. When it can compress no further, it bounces outward and expands again. In this model, the Big Bang was not the first beginning. It was a rebound, like a ball hitting the ground and rising back up. Before the bounce, there may have been a universe shrinking inward, filled with stars, galaxies, and maybe even life. If this is true, then our universe is part of a long chain of universes, each born from the collapse of the one before it. The Big Bang would be just one beat in an endless cosmic rhythm. Another idea imagines the universe as a tiny bubble floating in a larger ocean of space. That ocean might be filled with countless other bubbles, other universes, each forming from small fluctuations. In this picture, the Big Bang was the moment our bubble began to expand. But the ocean was already there long before, and just like bubbles, universes might grow, collide, or break apart. What existed before our Big Bang could have been a vast landscape of other universes, each with its own rules and shapes. There is also the idea of a quiet, timeless state before the Big Bang, a state with no movement, no heat, no light. Not empty, but still, like a calm lake at dawn before the first ripple forms. In this model, the universe woke up when a small event disturbed that calm, a tiny spark that caused space to expand. The Big Bang would then be the first ripple on the lake, but the lake existed long before the ripple formed. Some theories even suggest that time may have flowed in a different direction before the Big Bang. Time might not be a single straight line, but something that can bend or reverse under extreme conditions. In this idea, a universe might exist before ours, but the meaning of before would be very different. Time would not match our sense of past and future. It would be as if the universe turned a corner, and our version of time began after that turn. But one of the most interesting possibilities is that the laws of physics themselves were different before the Big Bang. The rules that shape our world, gravity, light, matter, may have formed as the universe expanded and cooled. Before that, the universe might have followed a different set of rules entirely. In such a place, life, if it existed, would be nothing like life as we know it. It might not even be made of matter. It might not need space in the way we do. It could have been a pattern, a wave, or something we cannot describe with our current language. All these ideas share one gentle truth. The Big Bang does not have to be the absolute start. It might simply be the earliest moment we can detect, like the first chapter of a very old book. The pages before it may be torn, faded, or written in a different language, but the book itself could be much longer than we once believed. As we continue through this documentary, we will explore these possibilities carefully. Cosmic cycles, ancient universes, higher dimensional beginnings, and the quiet state that may have existed before time. To move deeper into this question, imagine the universe as a story written on a long scroll. We can read only the part that is unrolled. The Big Bang marks the beginning of the visible scroll, the part we can study through light and physics. But the rolled up section, the part still hidden, may contain the events that led up to it. We cannot see that hidden part, but the fact that the visible story begins so suddenly suggests that something set the stage before the scroll opened. One idea that brings clarity is the concept of quantum fluctuations. In the smallest scales of reality, space is never completely empty. It flickers with tiny bursts of energy. Particles appear for a moment and vanish again. This restless behavior may have existed long before the Big Bang. Picture a calm field full of tiny fireflies blinking in and out of existence. Most blinks are too small to grow into anything larger, but one blink, one fluctuation, might grow instead of fading. It might stretch, expand, and become the early universe. In this idea, the Big Bang was not the beginning of everything. It was the moment one spark grew bright enough to light up space. Another way to think about this is with a simple analogy. Imagine a grain of sand on a windy beach. 99 grains stay where they are, but one grain is lifted by the wind and carried upward, rising into the air. That one grain experiences a new environment. In the same way, our universe could be the grain of sand lifted by a rare fluctuation, while many other fluctuations remain tiny and silent. But what about the landscape those fluctuations came from? What existed before the spark? Some scientists picture a vast quantum sea, a timeless, silent state filled with potential but no structure. No galaxies, no matter, no motion. Just the raw ingredients for the universe waiting to be stirred. When the Big Bang happened, it was not from nothing. but from this sea of possibilities. A different idea comes from the concept of higher dimensions. Our universe may be like a sheet floating in a larger space with more dimensions than we can see. If two such sheets drift close and collide, the energy of their collision might appear to us as a Big Bang. That means the event that started our universe was caused by something in a higher space, a larger environment in which our universe is only one surface. Before the Big Bang, those two sheets existed, moving, bending, drifting. Their collision was the beginning of our story, but not the beginning of theirs. This picture is like two waves on a lake meeting. The splash looks sudden and dramatic, but the waves existed long before they touched. The lake existed before the waves, and the water existed before the lake formed. Reality may have layers like this, levels of structure deeper than the one we see. Another gentle idea is the baby universe theory. It suggests that universes might grow from the collapse of stars in another universe. When a massive star collapses into a black hole, the space inside becomes extremely dense and hot. Some scientists propose that inside this extreme environment, a new universe could begin, sealed away from the parent universe by the black hole's boundary. If so, then our universe may have grown from the collapse of something that lived before us. The Big Bang would be the moment our cosmic seed opened from the inside. This concept leads to a peaceful thought. Universes might be connected like branches of a tree, new ones growing from old ones, each with its own rules and possibilities. We live on one branch, unaware of the others. And yet, with all these ideas, the truth remains that we cannot yet see beyond the earliest light. The time before the Big Bang is like a silent valley hidden by mountains. We can sense that the valley exists. We can imagine what it might contain, but we cannot yet walk inside. Still, the fact that we can imagine these possibilities is powerful. It suggests that the universe has a history deeper and richer than the one written in stars. A history that begins not with a flash, but with a quiet setting waiting to unfold. To understand what might have existed before the Big Bang, we need to think carefully about what the Big Bang actually represents. It is not an explosion in space. It is the creation of space itself. When we picture the Big Bang as a fireball bursting outward, we are imagining it incorrectly. There was no outside for it to burst into. Space expanded from within itself. Time began flowing. The ingredients of the universe settled into patterns. But even if space and time began at this moment, it does not mean reality itself began here. It only means that our version of space and time did. Imagine walking into a room just after a candle has been lit. You see the flame, the light, the shadows it creates, but you cannot see the moment before the candle was lit, unless you know what signs to look for. Perhaps there's the smell of burned wick, or the faint warmth left behind from a match. The Big Bang might be like this candle. We see the universe after it lit up, but we have hints, very small ones, that something happened beforehand. One clue comes from the extremely smooth temperature of the universe. When we look at the cosmic microwave background, the faint glow left over from the early universe, we notice something strange. The temperature is almost perfectly even everywhere. For this to happen, different regions of the universe would have had to talk to each other before the Big Bang began expanding. But according to our simple picture, those regions were too far apart to do so. This suggests that something existed before expansion that allowed everything to settle into a calm, smooth state. Something must have prepared the universe, as though setting a stage before the performance began. Some theories propose that the universe before the Big Bang was in a quiet, slow-changing condition called the false vacuum. This is not empty space. It is a kind of high-energy field that can sit still for a long time. But eventually, like a soap bubble popping, the false vacuum can collapse, releasing energy and creating a burst of expansion. If this happened, then our universe began when a calm, smooth field suddenly shifted into a more active state. The Big Bang would be the moment the bubble broke, but the bubble existed before it. Other theories suggest a geometric origin. Think of a piece of paper rolled tightly into a tube. If you unroll it, the flat shape appears larger. The Big Bang might have been like unrolling a dimension, allowing space to expand. Before this unrolling, the universe might have been compact but still present, folded in ways we cannot view. Now imagine a child's slinky toy. When compressed, its shape is tight and small. When released, it stretches smoothly. Some scientists imagine the early universe as a compressed shape of space-time. When conditions changed, the shape expanded outward. The expansion felt like a beginning, but the slinky existed before it stretched. Another idea that helps is the image of a frozen lake. Before spring, the lake is still. Beneath the ice, particles move slowly. But when the ice melts, the water becomes active, flowing and shifting. The Big Bang could have been the moment a frozen state of space melted into motion, releasing energy and creating all the structure we see. But the frozen lake, the earlier phase of reality, was still there before the melting began. There is also the concept of a mirror universe. In this idea, time flows in both directions from the Big Bang. Our universe expands forward, while another universe expands backward in time. Both emerge from the same point, like reflections facing away from each other. In this view, the Big Bang is not a beginning, but a bridge between two universes, with time moving in opposite directions. What existed before the Big Bang then? It could have been a quiet field waiting to change. It could have been a previous universe collapsing inward. It could have been two higher dimensional surfaces drifting in a larger space. It could even have been a timeless state where time itself had not yet started. The important thing is this: the Big Bang is not the end of understanding, but the beginning of questions. And in those questions, we find a gentle, humbling thought that the universe we see, with its stars and galaxies, may be only one phase in a much older and deeper cosmic story. To understand the time before the Big Bang, it helps to think about how nature often hides its deepest processes beneath simple surfaces. A seed becoming a tree seems sudden when you look only at the final plant. But inside the seed, countless steps took place long before the first leaf appeared. The Big Bang might be like that leaf, the first visible sign of something that had already been unfolding quietly. One of the most interesting ideas is that the universe began not from empty space, but from a field, a kind of invisible ocean that fills everything. This field might have existed long before the Big Bang, sitting in a calm, stable state. But like water in a pot that suddenly begins to boil, the field might have reached a point where it could not stay calm anymore. It released its energy, and that release became the expansion we call the Big Bang. In this view, The universe came from a shift in a deeper layer of reality, not from nothing at all. Another simple way to picture this is with a stretched rubber band. As you stretch it, tension builds up. When you finally let go, it snaps back with energy. Some scientists propose that space itself may have been under tension before the Big Bang. That tension built quietly, silently, until it reached a point where it had to release. The release became an explosion of space, not into something, but as something. A different idea imagines the universe as part of a cycle. Just as seasons repeat, the universe might go through endless rounds of birth, growth, and collapse. Imagine breathing in and out, expansion, then contraction. If this cycle is real, then there may have been a universe before ours that slowly collapsed inward. It shrank until it reached an extremely small, dense state. And then, instead of staying collapsed, it rebounded. And that rebound was our Big Bang. If this is true, then the Big Bang was not a beginning at all. It was a transition, the bridge between an older universe and our own. Now picture a simple pendulum swinging back and forth. It reaches one extreme, slows down, and then swings the other way. The moment it turns around is brief but important. The Big Bang might be such a turning point, a moment where contraction ended and expansion began. Some theories take a different approach. They imagine that our universe is like a bubble forming in a much larger space. This larger space is sometimes called the multiverse. Not a place we can travel to, but a bigger context where many universes can appear. In this idea, the Big Bang was the moment our bubble formed and began to grow. But the environment that allowed the bubble to form existed long before. It may still exist, with countless other bubbles forming all the time. Think of soap bubbles rising in a sink. They appear suddenly, shining and expanding. Each one has its own shape and story. But the water and soap mixture existed before any bubble appeared. In the same way, the Big Bang may have been a moment when conditions in a deeper reality allowed a new universe to form. Another gentle idea is that before the Big Bang, time itself may not have flowed the way we know it. Time might have been slow, stretched, or even frozen. Imagine a clock that stands still and then suddenly starts ticking. The Big Bang could have been the moment the cosmic clock began. But even a frozen clock still exists. The moment before is simply timeless, not empty. This idea can be compared to winter soil. On the surface, nothing moves. The ground seems dead. But beneath the frozen layer, seeds wait, holding the silent potential of spring. The Big Bang could have been that sudden moment of thaw, when potential began to unfold into motion, light, and matter. Many of these ideas share one comforting truth. The universe may have roots that reach far deeper than we can currently see. The Big Bang may have been a beginning for us, but not for reality as a whole. Something, whether a field, a cycle, a larger space, or a quiet, timeless state, may have set the stage. And even though we cannot yet look past the Big Bang directly, our observations of the universe, its smoothness, its energy patterns, its structure, suggest that traces of the earlier state remain. They are like faint footprints leading back into the darkness, hinting at a path we have not yet traveled. As we continue, we will explore what these traces might tell us about the deeper story of the cosmos and why the universe may be older, richer, and more mysterious than a single beginning implies. To understand what may have happened before the Big Bang, it helps to step back and think about how nature often hides complexity beneath simple outcomes. When we look at a calm lake, we see only the smooth surface, but beneath it, currents swirl, temperatures shift, and life moves. The Big Bang might be similar. We see the surface, an expanding universe, but beneath that surface, something deeper may have been happening long before the moment of expansion. One idea scientists explore is that the universe began in a state of extreme symmetry. In this state, everything was balanced. No differences, no structures, no separate forces. Perfect stillness in the laws of physics. But perfect symmetry is unstable. A tiny disturbance can break it, the same way a perfectly balanced pencil eventually falls to one side. When the symmetry broke, the universe may have chosen a direction, creating space, time, and energy. The Big Bang could have been this very moment, the falling pencil, the break in balance, while the balanced state existed quietly beforehand. Imagine a room full of identical candles that have not yet been lit. The candles are real, the room is real, but nothing is happening. Then one candle lights, and suddenly the room changes. The Big Bang was like the lighting of the candle, but the room existed before the flame. Another idea comes from the concept of imaginary time, a mathematical way of describing the universe before the Big Bang. In this view, time behaves almost like a direction in space. Instead of running forward or backward, it curls smoothly. There is no sharp beginning, just a rounded shape. You can picture this like the rounded top of a hill. When you walk down the hill, you move into normal time. But the rounded peak, the region before, did not have ordinary time at all. It was not a moment before time. It was a different kind of time, a soft, gradual transition. This is like a sunrise. There is no exact second when darkness becomes daylight. Instead, the sky brightens slowly. The Big Bang might have been the moment the sky became bright enough for us to see, while the gentle glow before it, this imaginary time region, remained hidden. Another possibility is that the universe began as a tiny loop of energy, a closed circle with no inside or outside. This loop might vibrate, expand, and eventually grow into the universe we know. If this is true, then before the Big Bang, the universe was not empty. It was small, quiet, and looping through itself. A circle without a start or end. The Big Bang would be the moment the loop stretched into a full, expanding space. Think of a rubber band. When relaxed, it is small and circular. When stretched, it becomes larger and can take different shapes. The early universe may have been like that rubber band, suddenly stretching from a tiny shape into a growing cosmos. Some models even describe the universe before the Big Bang as a smooth field of uniform energy. No stars, no particles, no movement, just a calm, even field. For reasons not yet understood, this field might have become unstable. Maybe a quantum fluctuation nudged it. Maybe a deeper rule of physics changed. Whatever the cause, the calm field could have rolled downhill, releasing energy and creating the hot, expanding universe we see today. The Big Bang, in this view, is not the start of everything. It is the moment the calm field changed its shape. This is similar to a ball resting on a hill. The ball sits quietly until a small push sends it rolling. The rolling is dramatic and visible. The resting state is quiet but real. The Big Bang is the roll. The resting state is the time before. Another idea imagines that the universe formed through a rare transition, the same way water can suddenly freeze or suddenly boil when conditions shift. Before the Big Bang, reality might have been in a different phase. When a shift occurred, everything changed. Space expanded. Time began to flow. Matter appeared. It was not the beginning of existence. It was a phase change, like liquid becoming gas. These ideas share a common theme. They do not place reality in a void before the Big Bang. Instead, they describe a universe that was quiet, smooth, compact, or symmetric, different from our universe, but still present in some form. The Big Bang was the moment the calm state became active, dynamic, and bright. This means the question, what happened before, might not be about a single event, but about understanding the deeper state that transformed into our universe. As we continue, we will explore even more possibilities, collisions in higher dimensions, the idea of multiple universes growing like branches of a tree, and what clues we might already have from the way our universe behaves today. To explore what may have existed before the Big Bang, it helps to imagine the universe not as a single object, but as part of a larger landscape, something like a forest. When you walk into a forest, you see trees of different ages, some young, small, and new, others old, tall, and ancient. The Big Bang may have created our tree, but it does not rule out the possibility that many other trees already existed before ours began. One idea scientists explore is the eternal inflation model. In this picture, space is always expanding somewhere. The expansion never stops. It continues endlessly, like wind blowing across a field. But in some regions, the expansion slows down, allowing bubbles of stable space to form. Each bubble becomes a universe. Our universe is one such bubble, but countless others may have formed before it, and countless others may form after. Picture soap bubbles rising in a sink. Each bubble expands, floats, and drifts, but the soapy water creating them existed long before any bubble appeared. Similarly, the energy that causes inflation may have existed before our Big Bang, quietly creating a landscape where universes appear again and again. In this idea, what happened before the Big Bang? Possibly another universe inflated and drifted in a cosmic sea long before ours began. Another idea comes from the concept of brain cosmology. In this picture, our universe is not the whole of reality. Instead, it is a three-dimensional brain floating in a space with more dimensions than we can sense. Other brains, other universes, might float beside ours like pages in a book. Normally, these pages do not touch, but if two brains collide, the energy released could create something like the Big Bang. This means our universe may have begun when a neighboring universe brushed against ours. That collision could have happened after long periods of drifting, bending, and stretching in higher space. The time before the Big Bang, then, might have been a calm era in which two brains slowly approached each other, unaware that their meeting would create a new universe. Imagine two waves moving across the surface of a lake. They roll in silence for a while, then meet. The moment they meet, a splash forms, quick, bright, full of motion. The splash begins suddenly, but the waves existed long before it. Our Big Bang could be that splash. Another gentle idea involves the collapse of previous universes. In this view, universes grow old, expand, and cool. Over time, they become thin and quiet. Eventually, they may collapse inward due to gravity. As they shrink, they become denser and hotter. When they collapse completely, the extreme conditions could trigger the birth of a new universe, sealed off from the old one. In this model, Our universe may be the daughter of an older universe that collapsed long ago. The Big Bang was the moment it emerged from the old universe's final stage, like a new leaf growing from the remains of a fallen tree. Now consider another idea, a universe without a true beginning or end. Instead, it cycles endlessly through phases of calm and activity. Before the Big Bang, the universe could have been in a phase of slow contraction or in a stable, quiet state. After that calm period, a sudden shift triggered expansion. The cycle might repeat endlessly, with each universe leaving faint marks on the next. This is similar to a heartbeat. Each beat begins suddenly, but the heart itself continues through a rhythm that stretches far before and after any single beat. Our universe may be experiencing just one beat in a much longer cosmic pulse. Another possibility is that time itself behaves differently before the Big Bang. Perhaps time does not stretch backward forever. Instead, it may curve or loop, making the Big Bang a turning point rather than a start. Before the turn, time could have flowed in a different direction, following rules we have not yet discovered. Imagine walking along a path that curves gently. You cannot see beyond the bend, but the path continues. The Big Bang might be such a bend, an inflection point in the flow of time where everything changes direction. These ideas show that a great variety of possibilities existed before the Big Bang. Calm fields, older universes, drifting brains, expanding bubbles, collapsing cycles, and time flowing in unfamiliar ways. Each one offers a slightly different view of what reality might have been before our universe lit up. As we move forward, we will explore how scientists search for clues of this earlier reality and why the traces might still be hidden in the structure of space around us. To understand what might have existed before the Big Bang, we can look at the quiet signals the universe still carries, small hints that something older may have touched our cosmos long before its earliest light. These clues are subtle, almost like faint fingerprints left on glass. They do not reveal the full picture, but they suggest that the universe may remember more than we can currently see. One of the biggest clues is the uniformity of the universe. When scientists look at the cosmic microwave background, the oldest light we can observe, they find it is almost perfectly smooth. Different regions of the sky have nearly the same temperature. This is surprising because those regions are so far apart that they could not have shared information after the Big Bang. They had no time to exchange heat or energy, and yet they match. This suggests that something connected those regions before the Big Bang's expansion. Something allowed the universe to settle into that smooth state. It is like walking into a room and seeing that all the candles are burning at exactly the same height. You suspect someone arranged them before you arrived. The universe's smoothness may be that arrangement. Another clue comes from the distribution of galaxies. On very large scales, galaxies are arranged in giant patterns, threads, walls, and empty bubbles. These patterns look like the frozen ripples of ancient waves. Some scientists wonder whether these ripples might be echoes of something that happened before the Big Bang, patterns forming in an earlier universe and carried forward through the transition into ours. Imagine tapping a drum. The vibrations spread across the surface. Now imagine placing a thin sheet of paper on that drum. Some of the vibrations might still be visible on the paper. In the same way, the patterns we see in galaxies could be faint vibrations from a deeper event. Another subtle clue lies in the existence of matter itself. After the Big Bang, particles and energy should have formed in equal amounts of matter and antimatter. Instead, matter dominates our universe. Something tipped the balance. Something favored matter over antimatter. No one knows why, but some theories suggest the imbalance might have begun before the Big Bang, perhaps inherited from an earlier phase of reality with rules different from the ones we know. A different type of clue appears when we study black holes. Black holes compress matter and energy into incredibly dense states that might resemble the conditions before the Big Bang. Some theories propose that when a black hole forms in one universe, it could create a new universe inside it. In this scenario, the parent universe leaves fingerprints on the child universe. Our Big Bang could have been triggered inside such a black hole, influenced by patterns and laws from an older universe. If true, then the strange rules of our cosmos, like the strength of gravity or the speed of light, may be inherited traits passed down through cosmic generations. Now consider the possibility that the expansion of the universe itself contains a clue. Space is not just expanding, it is accelerating. Something is pushing galaxies apart faster and faster. We call this force dark energy, but we do not know what it is. Some theories propose that dark energy might be a leftover effect from a previous universe, like the fading warmth of a fire long extinguished. Dark energy could be the lingering memory of a time before ours began. There is also the idea of tiny scars in the cosmic microwave background, small circular patterns that could be leftover marks from collisions in a previous universe. These scars are debated heavily. Some scientists see them, others do not. But if they are real, they could be evidence of events that happened before our universe inflated, like ripples passing from one reality into the next. A gentler clue comes from the overall shape of the universe. Observations suggest the universe is extremely flat, meaning space is not curved inward or outward in extreme ways. This flatness is surprising. It is as if someone laid out a giant sheet and stretched it perfectly smooth before expanding it. Such smoothness might be the result of conditions that existed before the Big Bang. Imagine ironing a piece of fabric. Once smooth, the fabric will expand evenly if you pull on it. The universe's flatness may be the cosmic equivalent of a well-prepared sheet, waiting for expansion. Taken together, these clues form a quiet picture. Not a complete one, not a certain one, but a suggestion, gentle, faint, persistent, that the Big Bang was not the ultimate beginning. Something existed before. Something shaped the conditions. Something prepared the universe for the moment when space lit up. This is not a single answer, but a collection of hints pointing toward a larger story, one we are only beginning to understand. In the next parts, we will explore how different theories attempt to explain these clues and what reality itself may have looked like before the first spark of creation. To explore what might have existed before the Big Bang, it helps to think about the universe not as a single moment, but as a long unfolding process, one with phases, transitions, and hidden stages we can barely imagine. When we picture the Big Bang, we imagine a sudden, brilliant beginning. But beginnings in nature almost always have deeper roots. A volcano erupts, but deep underground the pressure has been building quietly. A storm appears, but air currents and temperature shifts have been preparing it for hours. The Big Bang may have been a similar eruption, dramatic, bright, and sudden from our point of view, but triggered by something deeper. One idea that helps visualize this is the concept of pre-Big Bang geometry. In this idea, space and time before the Big Bang were not arranged the way they are now. They might have been curved tightly together, forming a compact region with no room for galaxies or particles. When the geometry shifted, like a tightly folded paper suddenly flattening, the universe expanded rapidly. The Big Bang would then be the unfolding of this geometry, not the creation of space from nothing. A similar picture comes from thinking about phase transitions. Water can sit quietly at 0 degrees Celsius, still liquid, until just the right condition causes it to freeze suddenly. Or steam can sit quietly until a small dust particle causes it to condense into droplets. The universe might have been in a state like this before the Big Bang, quiet, balanced, waiting, and then a small fluctuation, a change in the underlying field, triggered a phase transition. Energy was released, the state changed, and expansion began. If this is true, the time before the Big Bang was not empty. It was a stable phase of something deeper, a smooth, calm field that suddenly shifted. Think of a blanket pulled tight. If you let go of one corner, the fabric snaps into a new shape. The Big Bang may have been the moment the fabric of reality changed shape. Another idea suggests that the universe may have been contracting before the Big Bang. Slowly, over vast stretches of time, space may have tightened. Galaxies may have drawn closer. Stars may have drifted inward. As everything compressed, temperatures rose and densities increased. When the universe reached a critical limit, instead of collapsing into nothing, it bounced outward. That bounce, the sudden reversal from contraction to expansion, is what we call the Big Bang. In this picture, the universe is like a beating heart. It expands, slows, contracts, reaches a minimum size, and then expands again. And if this is true, our universe might be just one cycle in a long chain of cosmic breaths. Another idea comes from string theory, where reality has more dimensions than we can see. In this picture, our universe might be like a sheet, floating in a larger, multi-dimensional space. If another sheet drifted close and touched ours, the collision could produce enormous energy, enough to trigger a Big Bang. The sheets might then drift apart again, leaving a new universe expanding between them. Before the collision, the sheets existed calmly in higher dimensions, shaping and moving in ways we cannot detect. A gentle way to imagine this is with two blankets waving in the wind. Eventually, they touch. The moment they touch, friction creates heat. That heat is sudden, but the blankets existed long before they touched. The Big Bang could be the heat from such a meeting. Another possibility is that the universe was born inside a black hole. When a star collapses, the region inside becomes dense beyond imagination. Some scientists propose that this density could trigger a new universe to form, a universe sealed inside the black hole, separate from the one that created it. The Big Bang, in this case, would be the moment the inner universe began expanding. The before would be the universe outside the black hole, a universe we cannot return to or observe. A simple analogy is a seed pod. Inside the pod, a new life begins. But from inside, the seed cannot see the plant that produced it. Our universe might be that seed. But there is an even quieter idea. Before the Big Bang, time might have behaved differently. Maybe time slowed as the universe approached an earlier state. Maybe it curved, looped, or flattened. If time was not flowing in the same way, then the question, what happened before, might not work. Instead, the Big Bang could have been the moment time became meaningful, the moment the clock began to tick. Imagine a frozen river. Before the ice melts, the water moves too slowly to notice. When the thaw begins, movement becomes clear. The Big Bang might be the thaw, the moment time began to flow in a way we can measure. All these ideas, cycles, collisions, transitions, compressions, higher dimensions, and different forms of time, try to answer the same peaceful question. What set the universe in motion? The Big Bang was a beginning for us, but not necessarily the beginning of everything. Something may have existed before, a calm field, a contracting universe, a higher dimensional landscape, or a timeless state waiting to awaken. As we continue, we will explore these possibilities one by one, slowly and clearly, and consider what each one says about the deeper nature of reality. To explore what may have existed before the Big Bang, let's imagine how nature transforms one state into another. A caterpillar becomes a butterfly. Ice becomes water. A star becomes a cloud of dust that later forms new stars. In every case, there is a moment of change, sometimes sudden, sometimes gentle, where one form becomes another. The Big Bang might have been such a moment. Not a creation from nothing, but a transformation from something older into something new. One idea that helps illustrate this is the concept of a quantum bridge. In the smaller scales, space and time behave in unpredictable ways. Distances fluctuate, energy appears and disappears, and the rules of cause and effect soften. If the universe began in such a quantum state, the Big Bang might have been the moment when these tiny, restless fluctuations built up enough energy to expand into a full universe. Before that expansion, there could have been a microscopic, hidden world where time barely moved and space barely existed. Think of a still ember in a fire pit. It glows quietly, almost invisible, until a small breath of air makes it flare into flame. The quantum state before the Big Bang might have been that ember, a quiet glow waiting for the right moment to awaken. Another concept is the pre-Big Bang curvature. Some theories propose that space before the Big Bang was curved inward, like a sphere. During the Big Bang, this curvature changed, flipping from inward to outward. When curvature flips, space expands rapidly. The change itself is dramatic, but the curved state existed before the flip. In this picture, the Big Bang is a sudden change in geometry, not a true beginning. Imagine turning a balloon inside out. The flip is quick, but the balloon itself existed on both sides of the transformation. A different idea suggests that the universe before the Big Bang was in a state of slow contraction. It shrank over an immense period of time, becoming smaller, smoother, and hotter. Eventually, it reached a point so dense that the laws of physics themselves changed. Instead of collapsing fully, the universe bounced, reversing direction. The bounce created the expansion we see today. In this model, the universe has no true beginning. It simply alternates between growing and shrinking, like a lung gently breathing. This is similar to standing at the shore and watching waves roll in and then retreat. Each wave begins suddenly, but the ocean itself continues in a long, continuous rhythm. Another theory proposes that the universe exists within a higher dimensional space. Imagine a flat sheet floating within a larger room. The sheet is our universe. The room is the higher dimensional world that surrounds it. If two such sheets drift close and collide, the energy from the collision could create a Big Bang. Before the collision, the sheets existed quietly, moving through higher space. Their meeting was not the beginning of everything, only the beginning of our universe. A calm picture of this idea is two clouds drifting across the sky. They touch, merge briefly, and then drift apart again. The merging moment is bright and active, but the clouds existed long before. Some scientists approach the question from another angle altogether. They propose that the universe might have begun inside a black hole in another universe. When a star collapses into a black hole, the density becomes extreme. Inside that extreme density, the conditions might create a new universe, disconnected from the one outside. The Big Bang, in this idea, is the moment the new universe began expanding from the core of a parent universe. The before lies beyond a boundary we cannot cross. This is like a plant dropping a seed. The seed grows into a new plant that never sees the original tree. But the tree was still its origin. Another gentle possibility is that before the Big Bang, there was no time at all. Not in the sense of emptiness, but in the sense that time did not flow. It did not pass. It simply wasn't part of reality yet. The Big Bang would then be the moment the universe gained structure and direction, the moment clocks could begin ticking. Asking what happened before, that would be like asking what happened before existed. Yet this idea does not deny a previous state. It simply says that the earlier state did not operate under the rules of time the way we understand it. Imagine a blank page before a story is written. The page exists, but the story has not started. When the first word appears, the story begins, but the page was still there, patiently waiting. As we bring these ideas together, we start to see a bigger picture. The Big Bang may have been a change, not a creation, a transition, not a sudden appearance. Something deeper may have been unfolding long before our universe lit up. Something calm, symmetrical, contracted, higher dimensional, or timeless may have set the stage. In the next part, we will explore these possibilities even further, what they imply about the nature of the cosmos, and what they suggest about the deeper reality that may lie beneath all universes. To understand what may have come before the Big Bang, we can think about how information travels through the universe. Even when objects disappear, traces of their existence remain. A fallen tree leaves rings behind that tell its age. A dried riverbed shows where water once flowed. In the same way, our universe carries faint marks, patterns, textures, and structures that may point to a time before the great expansion began. One of the most intriguing ideas is the possibility of a cosmic memory. This memory is not written in words or symbols, but in the shape of space itself. Some scientists believe that the way galaxies are arranged, the way matter clusters, and the way energy is spread out could be leftovers from an earlier universe. These patterns might be very faint, but not erased. Imagine drawing in soft clay. Even if you smooth the surface, small indentations remain. Our universe might be like that clay, still holding tiny impressions of a deeper past. Another idea is that the Big Bang may have been the transformation of a previous universe into ours. Picture a star collapsing into a black hole. Outside, the star disappears forever, but inside, the black hole could create a new region of expanding space, a new universe sealed off from the original. If our universe formed this way, then the before would be the universe that gave birth to the black hole. The Big Bang would be the inside view of that birth, the moment the new universe opened and began to grow. This creates a peaceful chain of events. One universe forms another, which forms another, like branches of a growing infinite tree. Another possibility comes from the idea of higher dimensional surfaces, or brains. In this model, our universe is like a floating sheet. Other sheets drift near us, possibly with their own physics, their own stars, and their own histories. If two brains collide, the energy released might start a Big Bang. That means our universe's beginning came from contact with something else in a larger dimensional space. Before the Big Bang, these brains may have drifted for ages, slowly approaching until the moment of collision. This is similar to two ships at sea drifting together, quiet and unaware, until their hulls gently touch. The touch is brief, but the ships existed long before. Other theories imagine an endlessly cycling universe, a cosmos that grows, slows, collapses, and then expands again. In this rhythm, the Big Bang is not a beginning, it is a turning point. Before it, the universe may have been collapsing inward, growing hotter and smaller. Then it reached a state where collapse could not continue. The energy reversed direction, and expansion began. In this view, the universe has no first chapter. It has an infinite series of chapters, each written in cycles. This cycle is like breathing. Each breath feels like its own moment, but breathing itself continues far before and far after any single inhale. Another gentle possibility is the existence of a timeless region, a phase where time did not flow the way it does now. In this region, nothing changed, yet everything existed as potential. When the Big Bang occurred, time began to flow, and potential became motion, heat, and matter. Asking what happened before that is like asking what happened before dawn. There was a world before sunrise, but within the dark, time had a different character. We can imagine this as a frozen river. Before the thaw, the water is still, solid, unchanged. After the thaw, the river begins to move. The thaw is a transformation, not a creation. The Big Bang may have been the cosmic thawing of reality. Another idea focuses on the symmetry of the early universe. Some theories suggest that before the Big Bang, everything was in perfect balance. No direction, no difference, no flow of time. When that balance broke, even slightly, the universe entered a phase where structures could form. The break in symmetry may have been the spark that started everything, but the balanced state, quiet and smooth, existed beforehand. This is like a pencil standing perfectly upright on its tip. For a moment, it is stable. Then, without warning, it falls to one side. The falling feels sudden, but the upright state was real before the motion began. The common thread through all these ideas is simple. The Big Bang does not have to be the first moment of reality. It may have been a change, a collision, a bounce, a thaw, or a transformation from a deeper, older state. In the next part, we will explore how these possibilities reshape our understanding of the universe and what they tell us about the nature of existence itself. To explore what may have existed before the Big Bang, we can look at a gentle idea that appears again and again in nature. The idea that origins are rarely simple. Rivers begin with countless small streams. Forests begin with seeds that come from earlier trees. Even the air we breathe comes from ancient stars that lived and died long before Earth formed. The universe too might follow this pattern. What we call the Big Bang may have been just one step in a much larger, older process. One possibility that captures this idea is the quantum seed model. In this view, the universe began as an impossibly tiny seed of energy. But that seed itself may not have been the first thing. It might have formed from deeper fluctuations in a larger reality. Think of a tiny spark rising from a campfire. The spark is bright for a moment, but it came from the fire beneath. Our Big Bang might be such a spark, ignited from a deeper fire of quantum fields. Another idea imagines a smooth, calm state before the Big Bang, something like a perfectly still ocean. In this state, there were no stars, no space, no time as we know it, just a quiet field of potential. Eventually, a small change may have disturbed this calm, creating a ripple. That ripple grew, expanded, and became the universe. The calm ocean existed before the wave, even though the wave is what captured our attention. Picture placing your finger gently into still water. The surface erupts into ripples, but the water itself existed long before you touched it. The Big Bang could be that first ripple. There is also the idea that the universe before the Big Bang was in a compressed form, a tiny, hot, dense state where space was curled up tightly. This compressed state might have existed for a long time, held in balance by forces we do not yet understand. When the balance broke, space expanded rapidly. The breaking of that balance was the Big Bang, but the compressed state existed beforehand. Imagine a coiled spring held tightly. It stores energy without moving. When released, it expands outward in a burst. The Big Bang might be the release of a cosmic spring. Another possibility is that the universe was once contracting. Over enormous periods of time, everything may have been drawn inward by gravity. Stars burned out. Galaxies drifted closer. Temperatures rose. Eventually, everything compressed into a single dense state. But instead of collapsing forever, the universe reached a point where the rules changed. The collapse reversed. The universe bounced outward. The bounce was the Big Bang, but the collapse came before it. This is like a ball thrown into the air. It rises slowly, stops for a moment, then falls. When it hits the ground, it bounces back up. Each bounce feels like a beginning, but the motion existed before. Other theories imagine multiple universes. Some may be older, some younger, some may be expanding, others contracting. If universes are constantly forming, ours may simply be one of many. In that case, the Big Bang is the start of our universe, but not the start of everything. Something existed before, a larger environment, a wider landscape where new universes appear like flowers blooming in a field. A calm way to picture this is to imagine a garden. Flowers bloom one after another, each with its own shape and time. But the soil beneath them, the foundation that allows them to grow, existed before any flower appeared. The multiverse could be that soil. Another idea proposes that the universe before the Big Bang had no ordinary time at all. Time may have been like a frozen dimension, a silent backdrop with no past or future. When the Big Bang happened, time melted into motion. Before that moment, asking what happened may not make sense, because without time, nothing can happen. Yet the frozen state was still real. It was simply quiet. This is like a river, frozen in winter. The ice holds the shape of the river, but nothing flows. When spring arrives, the ice melts, and the river begins to run. The Big Bang might be the spring thaw of time. There's also the idea of symmetry, a perfect, balanced state where all forces and energies were equal. No direction, no difference, no change. When that symmetry broke, the universe gained structure. The breaking created heat, energy, and expansion. But the perfectly balanced state existed first, silent and whole. Imagine a snowflake forming from a cold cloud. The cloud looks empty and uniform. Then suddenly, a crystal pattern appears. The snowflake feels like a beginning, but the cloud was there long before. All these ideas share one central message. The Big Bang may be the beginning of our universe, but not the beginning of existence itself. Something older, perhaps calm, perhaps contracting, perhaps drifting, perhaps timeless, may have preceded the moment of expansion. In the next part, we will explore what these ideas mean for the deeper nature of reality, whether the universe has a purpose, whether it is infinite, and whether there might be echoes of earlier universes woven into our own. To imagine what reality may have been like before the Big Bang, we can think about one of the most mysterious features of the universe, the fact that it follows rules. Gravity works everywhere. Light behaves the same way across billions of light years. Atoms form predictable patterns. This order raises a gentle question. Where did these rules come from? If the Big Bang created the universe, then perhaps the rules that guide everything originated before it. One idea suggests that the laws of physics may have been shaped in a previous universe. If universes form from earlier ones through collapse, bounce, or black hole creation, then each generation of universe may inherit certain traits. Gravity might be strong or weak, depending on how the previous universe collapsed. The amount of matter, the behavior of energy, and even the number of dimensions may be influenced by what came before. In this picture, our universe is not an isolated miracle. It is part of a long chain of evolving realities. Imagine a family tree. Each new branch grows from a previous one. The branch is unique, yet it carries the history of everything that came before it. Our universe could be one branch on a cosmic family tree. Another idea is that before the Big Bang, the universe existed in a state of pure potential, a kind of blueprint without form. In this blueprint, the laws of physics were not yet fixed. They were possibilities, waiting for a moment of transition. The Big Bang could have been that moment, when the blueprint became reality. But the blueprint itself existed earlier, silent and timeless. This is similar to a piece of music written on a page. Before the music is played, the notes are still there, holding meaning even in silence. The Big Bang might be the moment the music began, but the notes existed before the first sound. Some theories imagine a universe before the Big Bang that had very different laws. Time might have flowed differently. Space might have been curved inward. Matter might not have existed at all. Instead, the universe may have been filled with pure energy or with fields that were perfectly uniform. When conditions changed, perhaps through a fluctuation or a slow drift, this earlier universe transformed into the one we live in. The Big Bang was the transition point, not the beginning of reality. Think of a landscape changing seasons. Winter turns to spring, not because winter disappears, but because the season transforms. Spring begins suddenly, but the ground beneath the snow was always there. Another possibility is that the universe before the Big Bang was part of a larger dimensional structure. Our three-dimensional world may only be a surface or a slice of a deeper reality. That deeper reality could have been active long before our universe began expanding. If different slices intersect or interact, one intersection could create a burst of energy, a Big Bang. Before the burst, the higher dimensional space existed quietly, shaped by rules we have not yet discovered. This is like looking at the edge of a book. You see only a line, but the pages extend deep inside. The Big Bang might be the moment two of those pages brush together, creating our universe as a byproduct of a larger structure. Another gentle idea is that before the Big Bang, information existed without matter or space. Some scientists imagine a region where only patterns and relationships existed, no particles, no time, no light. When the Big Bang occurred, these patterns crystallized into the laws of physics, shaping the behavior of everything that followed. In this picture, reality began as a web of connections that later became the universe we see. This is like a story taking shape in an author's mind before it is written. The ideas and structure exist, even though the physical words have not yet appeared. There is also the possibility that the universe before the Big Bang was infinite and eternal, without a beginning. In this view, the Big Bang is simply the moment we can observe, not the actual start of everything. If space and time extend infinitely, then the Big Bang is like a bright flare along an infinite timeline, important to us, but only a moment in a much larger flow. Reality might have no first chapter at all. This is like walking along a coastline. You see where the tide begins and ends in front of you, but the ocean stretches beyond the horizon. The Big Bang may be the edge we can see, not the edge that exists. As we bring these ideas together, one thing becomes clear. The universe may be far older, far broader, and far more layered than the Big Bang alone suggests. Whether through cycles, higher dimensions, deep fields, or timeless states, something may have shaped our universe long before it expanded. In the final part, we will explore what all of this means for our place in the cosmos, and why the question of before may be one of the most important questions we can ask. As we reach the final part of this journey, let's return to the heart of the question. What if there was something before the Big Bang? Not a speculation for its own sake, but as a gentle way to expand how we think about the universe, its age, its depth, and our place within it. If the Big Bang was not the absolute beginning, then the universe is richer than we ever imagined. It means the cosmos may have roots stretching into realms we cannot yet observe. It means our universe may be one chapter in a story far older and far broader than our current tools allow us to see. One idea we explored is that the universe before the Big Bang might have been perfectly calm, smooth, silent, and filled with potential. In this state, space and time may not have moved. Everything was balanced. Then the balance broke, and the universe blossomed into motion. In this view, the Big Bang was like the first breath after a long, silent pause. Another possibility is that our universe is part of a cycle, expanding and contracting through endless ages. If this is true, then countless universes may have come before us. Their stars lived and died, their galaxies spun and faded, and when each universe collapsed, the energy stored within it became the seed for the next expansion. Our universe might be one heartbeat in an eternal rhythm. We also explored the idea that the Big Bang could have been caused by a collision, two higher dimensional surfaces brushing together, releasing energy into a new universe. If that picture is correct, then before the Big Bang, there existed a larger space where entire universes drift, move, and interact. Our universe would be a ripple in a deeper sea. And then there is the idea that universes form inside black holes. In that model, the Big Bang was the opening moment of a new cosmos forming behind the horizon of a collapsing star in another universe. The before would be a parent universe we can never return to, but whose influence may live on in the properties of our own. We imagined universes forming like bubbles in a vast cosmic foam, each bubble emerging from fluctuations in a deeper field. In that view, the Big Bang was simply the moment our bubble grew large enough to become a universe. But the foam existed long before. We also considered the possibility that time itself behaved differently before the Big Bang, that there was no past in the familiar sense, only a quiet, timeless region that transformed into flowing time when the Big Bang began. Asking what happened before would then be like asking what sound came before silence. The silence was still real, just not something that moves. All these ideas lead to one soft, humbling conclusion. The Big Bang may not mark the birth of existence. It may be the birth of our universe, but not the birth of reality itself. The universe we see is full of patterns, smoothness in the cosmic background, the strength of gravity, the distribution of matter, the speed at which galaxies drift apart. These patterns may be clues, quiet signatures from something older, gentle echoes from a time before our universe expanded. And so, the question is not simply what came before the Big Bang. The deeper question is, how far back does reality go? Does it stretch endlessly into cycles? Does it branch into infinite universes? Does it rest in silent fields that awaken from time to time? Does it flow through dimensions beyond our reach? Or is it all of these together? Layers of reality woven into something far richer than we have ever imagined. As you picture the night sky now, the stars, the quiet dark, the gentle stretch of space, remember that everything you see is part of this long, unfolding story. A story that may have begun long before the first spark of light. A story written in cycles, collisions, fields, or timeless calm. A story that continues far beyond the edge of our observable universe. We may never know the full answer, but the beauty lies in the possibility. The universe invites us to wonder, to imagine, and to accept that our world might be only one layer of a far deeper reality. In the stillness of the night, it is enough to know that we live in a universe with a past far more mysterious than we can see, and a future just as vast and open. The Big Bang is not a wall, but a doorway, and beyond that doorway, the story of existence stretches into realms we have only begun to dream about. Whenever you are ready, I can help you start another 14-part script, refine the tone, or create a full combined version for narration.